Hi, welcome back, Introstat students. Today we are doing this exercise, calculating the p-value in a t-test for a mean. Okay, so looking at this, it says Evelyn was testing a null hypothesis of mu equals to 52 versus the alternate hypothesis is mu less than 52. With a sample of 9 observations, her test statistics was t equals to negative 2.83. Assuming that the conditions for inference were met, what is the approximate p-value for Evelyn's test? So it looks like there's a whole bunch of p-values. So if you can find the p-value and fit into the interval, whichever the interval is, that should be what you needed to do. So now let's take a look at what is needed here. So right here, if I were to draw a t distribution, okay, and then put in the t statistics, now here it's still going to be 0. T statistics negative, let's say it's here, negative 2.83. All right, and so assuming this is t, right? It's supposed to be a t distribution, okay? Because when you deal with means, you will most likely deal with a t distribution because your population standard deviation is unknown. Okay, so that's why we have a t distribution. So look at this arrow. This is a less than sign. So what we're trying to do is we're trying to find that is your p-value, right? That is your p-value. Now, how do I find p-value for a t distribution? We cannot use normal CDF. No, normal CDF is used for Z distribution. So this is T, we have to use T CDF, right? And T CDF has only 3 things instead of 4. So the first thing is your lower, second thing is your upper bound, and third thing is this interesting thing called degrees of freedom, DF. And degrees of freedom is sample size minus 1. So here, the lower will be, this is going to infinity, right? It's not going to stop. So you're going to put here negative 99999. Upper is this particular upper bound is negative 2.83. And degrees of freedom, here is a sample size of 9. 9 minus 1 is 8. So you got to put this in your calculator. So where do I find TCDF? Right? It's a new thing, right? It's not normal CDF, it's T because you're using a T distribution. And you got to go to second vars. Okay, so if you go to second vars, and then do you see a TCDF number 6? They're gonna ask you for 3 things: lower, upper, and degrees of freedom. So the lower will be negative 99999. Upper will be negative 2.83, right here. All right, and the reason why we're going this direction is because the alternative hypothesis says so. So we're going to go that direction. And degrees of freedom is 8 because it's 9 minus 1. So what's the p-value? 0.011. So 0.011. And 0.011, it's between here. It's between 0.01 and 0.05. Okay, so let's go to the next question. Um, Jasper was testing H naught, right? Your null hypothesis mean equals to 36 versus alternate hypothesis mean is not equals to 36 with a sample of 16 observations. His test statistics was T equals to 2.4. So now notice this. Earlier, the previous question was less than, right? Previous question, that's why we go into that direction. Remember, we choose this and we go in one direction. Now, this is not equals to. Not equals to is actually two direction. It's a two-tail test, right? It's going one direction here, right? It's going one direction here. So Now this is 0, right, for a t distribution, t standard t, and then 2.4 is what? 2.4 is about 2.4 around here. You need to go to the opposite end. So you need to put a negative sign here and put it on the opposite side. So this is negative 2.4. And so we're going to use TCDF, right? Now there are two areas and they are identical. So what we can do is we can just find one and multiply it by 2. Okay?
Attention Derek Davis, please head to Mr. Bernard's room. Derek Davis, please go to E203 for Mr. Bernard.
So TCDF, the lower bound is, let's try to find this one, right? And then we multiply by 2. So negative 99999, and the upper bound is negative 2.4. Degrees of freedom is 16 minus 1, right? Sample size is 16. 16 minus 1 is 15. So if I go to my calculator, I put second vars, and then go to TCDF, and then, okay, lower bound is negative 99999, upper bound is negative 2.4, all right? And then degrees of freedom is 15. Voila. Okay, so but I only found one side. Now I want to actually show you something. If I had done the other direction, so second verse, and I go to second verse, and I go to TCDF, and if I have gone the other direction, and I put 2.4 as my lower bound, and my 99999 as my upper bound, same degrees of freedom. Did you see that they're both the same? They're both the same area because they're identical, and I need to multiply by 2. So it's 0.0298. So it's between 0.02 and 0.04. Okay? So I hope this makes sense, and let me know if you have any question. Oh, this is greater than. Oh, we can do this. So greater than, let's draw the picture, which is actually very useful. So here will be 1.368, right? And because it's greater than, we're going to shade this one side. And we just need to worry about one side. This is my p-value. I do not have to worry about this side anymore. So, right, we need to put into our calculator second bars. You go to TCDF. So the lower bound was this, 1.368. Upper bound was 99999. And then degrees of freedom is 10 because sample size is 11. Okay, 0.1. So it's 0.101. Okay, if you have any questions, let me know. Thank you very much.